like till now we will discussed here the BGP neighborships, right? Okay, and this update source command is also done, right? And this eBGP multi-hop 2 command is also done. Disable connected check command is also done. Allows AS yesterday I told you, right? Okay. Now I'll make a new topology here for you. Okay, one more concept is there. Here what? Okay. So I have a question for you guys. The question is what? Let's say we have a router R1 and we have a router R2 and we have a router R3, right? And I'm using here IBGP, and here also it is IBGP, right? And this R1 router having an IP address, or we can say the loopback, that is 1.1.1.1/32, correct? And if I enable the BGP here, if I enable the BGP here as well, and if I'll enable the BGP here as well, so the problem is what? This R3 router is not able to receive the route, right? So what is the solution? If this R3 router wants to receive the route, so what is the solution?
The solution would be to, the question is, and like to configure the, what you told us, indirectly configure through the loopback or through the interface.
No, let's say I enable the BGP. I want to enable the BGP here as well, and here as well. So I'm enable the BGP on these 3 routers. And you know, the IBGP loop prevention mechanism, whenever this R1 router will share the prefix to R2, R2 is not able to share this prefix to R3, right? Yes. So the concern is what? R3 is not able to receive that route, and I want to receive that route. So what is the solution?
Do the allow as command.
No, not allow as.
No, I remember there was something else I had to do. This we saw yesterday.
Yes, if it's IBGP, for example, by default, IBGP will only share the prefixes only on the second router, but the third router, if it's the same ESN, it won't share.
Isn't it that we have to use the route reflector command?
Yes, perfect.
Exactly.
We are using route reflector to break a IBGP loop prevention mechanism, or to break a split horizon rule, right? Exactly, so we are the first solution is what? RR, right? The first solution is what? RR. And we have the second solution as well. What? The second solution? Okay. The second solution is what? Do one thing. Let's go on R1 router. Okay. Let's go on R1 router and then say what? Router. Let's say here I'm configured 10.1, 10.2, 20.1, 20.2, correct? Okay, so I'll say here what? Router, BGP, and then say what? 100, and then say what? Neighbor. Neighbor is what? 10.2, and I also say neighbor 20.2. Getting a point?
Okay, so I have 2 neighbors.
It means I'm creating a neighborship. First, I'll create the neighborship from R1 to R2, and then I also create the neighborship from R1 to R3.
Okay.
Okay, it means this topologies look like this. Indirectly, we can say this topology look like this, like R1. R1 is also connected with R2, and R1 is also connected with R3.
Okay.
Okay, getting a point? Because I'll make a neighborship with R1 to R2 right? And I also make a neighborship with R1 to R3. So using this concept, okay, so it means what I can do on R1, I'm saying my neighbor is what, 10.2 and 20.2, but on R2 I'm saying what, router BGP and then say 100, and my neighbor is what, my neighbor is only 10.1, okay, and on R2, yes, on R2 I also say my neighbor is what,
20.2.
20.2, okay. On R3 I'm saying what, router BGP and then say what, 100, and then say my neighbor is what, 20.1, and I'm saying my neighbor is what, 10.1. So in this condition, no need to enable any RR. Yes or no?
Don't need to enable? What was?
No need to enable any RR. You know, the problem is what? When I enable the BGP on R1, R2 and R3, so R1 will share this prefix to R2, but R2 is not able to share this prefix to R3. So what we need to do? Okay. We need to enable the RR. Okay. We need to enable the RR. Then R3 router will receive the route. But when we are doing a configuration like this, so yes, R3 router will receive the route. Yes or no?
Well, it's supposedly yes, right?
Theoretically, yes, but does it have to? But what question? Does it have to have another interface connect, or it's by the same interface?
The question is, if we don't use the RR, what will be another method, basically?
Yeah, exactly. Yes. That will be the method.
So in this case, what he's saying is that if you add all the networks on each router BGP configuration, I don't know if it's going to receive it or not. That's the question, actually.
Yes. It will receive. It will receive, actually.
It will receive. So see, this is another method to use.
Create just another network. I mean, another neighbor. Huh.
Yes. So on R1, I'm saying I have a neighbor that is R2, and also I'm saying my neighbor is what? R3 as well. It means R1 having two neighbors. I'll create two neighbors. Okay. And exactly same on R2. I'm saying my neighbor is this one and my neighbor is this one. Exactly same in case of R3. R3 is also saying my neighbor is what? R2 and my neighbor is what? R1. Correct?
Question. Isn't that going to create any type of loop?
No.
Okay.
Because the split horizon rule is enabled, right? Because actually what happened, once this R1 router will share any route to R2, but R2 is not able to share this route to R3. So R2 is not share those route to R3. R3 will receive that route directly from R1.
Okay. Just okay.
Not so via R2.
So what is this called? This type of topology?
This is called what? This is called what we call the first solution is what? That is RR, and the second solution is what? I forget the name.
Maybe network something.
No. This is called. Give me a second.
Sure.
Yes, this is called what? Full mesh.
Full mesh.
Full BGP mesh?
Yes. Full mesh. Full mesh is what? It means all routers having a neighborship to with all routers. Let's take an example. If we have this type of topology, R1, R2, R3, R4, R5, R6, R7, R8, R9, correct? right? This is the topology, right? So what I can do in this topology, I'll make the neighborship from R1 to R2, R1 to R5, R1 to R4, R1 to R3, R1 to R6, R1 to R9, R1 to R8, R1 to R7, correct?
Mhm.
And exactly same from exactly same. Give me a second. Okay, now. So, okay. So it means this is called, now we need to create a neighborship from R4 to R1, R4 to R2, R4 to R3, R4 to R6, R4 to R5, like this, like this, like this. Okay. After that, we need to configure R2 to R1, R2 to R4, R7, R5, R8, R9, R6, R3. Then we have what? R3 to R2, R1, R4, R5, R6, R7, R8, R9, correct?
Yeah, in this case, it will be like very complex to add all the networks, right?
Yes.
In this
Correct.
specific situation.
So, yes. So it means if you want to configure, if you want to remove the IBGP, if you want to remove the IBGP loop prevention mechanism, so the first option is what? RR. The second option is what?
Full mesh.
Mesh, full mesh.
Full mesh configuration. But you told me in full mesh configuration, the problem is what? The command, this is very complex because you know, for if for each router we need a two command. First is what? Neighbor command. Second is what? Update source loopback command, right?
On
It
the
means
network, on the network.
yes. So it means the number of command is
High.
higher, or we can say the increases in the full mesh topology, right? So that's why we have a mechanism to reduce these commands. That mechanism is called what? IBGP neighbor peer group.
That's how that's the name. That's another method, or is part of the full mesh.
This is the method to reduce the number of commands, basically.
What
This
is the
is
name
not a
again?
part of full mesh. This is not a part of
Okay.
full mesh. Okay. This is the another method. If you want to reduce the number of commands, then we are using what? That concept that is called what? IBGP neighbor peer group.
So this is another option?
No, it's not another
Okay.
option. It's like a way to make it simple. Instead of doing a lot of commands, you can do this. This is called IBGP.
A lot of command using this mechanism, using this IBGP neighbor peer group. What we can do? The lot of command we can aggregate. Or we can say we can summarize those commands, because we are creating a peer group.
Okay.
Okay.
So it's
So
called
how
IBGP.
this peer?
It will be easier. It's easier to do it this way, maybe.
What can you repeat again?
No, it's easier using this method, like peer do the neighbor peer group instead of doing all the commands.
Yes, then we need to okay, actually what happening? See. What happened in this case actually? In case of what we call IBGP neighbor peer group. IBGP neighbor peer group. Actually, what I can do here, I'll create a group here. And let's say I'll create a group and that group name is what? CCIE. Okay. So no need to enter the command for each and every neighbor. Just to put the group name CCIE and that's it.
Okay.
Okay. How it works and what are the commands that we will discuss. Don't worry. Okay. So right now, just I told you one thing here. What if you want to break IBGP loop prevention mechanism? So the first option is what?
RR.
Second option is what?
The full mesh.
Full mesh.
And if you want to reduce the number of command, then we have what?
The IBGP neighbor peer group.
IBGP neighbor peer group, right?
Yes.
Okay. So what is this IBGP neighbor peer group that we will discuss later? Okay.
Good enough.
Yes. Now let's discuss one more thing. I'll make a topology for you now.
So basically, you can create a group, let's say BGP1, and then just a group in each router, basically. And it automatically will do all the commands.
Yes. Yes. Yeah.
Okay.
Don't worry. We will do that lab. Then you can understand easily. No problem. Okay. Just right now, I told you the feature only. Okay. How that feature work and what are the commands that we'll discuss later. So this is what AS 100. Here it is what AS 200. And here also it is what AS 200, right? So this is the topology. R5 router having a, let's say it's loopback 1.1.1.1/32. This router having 2.2.2.2/32. And these are the, let's say, these are the ISP routers. Done. Okay. So let's turn on the device. Device is turned on, and let's configure the IP one by one. First, I'll configure the IP on the ISPs. So let's go on ISP 1 first of all. Okay, now IP address is configured. Now on ISPs, let's go on R5. Stop this device. Stop this device. And configure as a R1. Configure as a R2. Now let's turn on the device. Done. Okay, and let's go on R2 as well. Done. IP addressing is done, right? Okay, so guys, let's configure the topology, and we can say like, let's configure the BGP here. Okay, so first of all, I'll configure the BGP in between R1 and ISP1, right? So how to configure? Just to say router BGP and then say what AS number will be what 200, and then say neighbor. Tell me the neighbor.
From R1.
This is R1. The neighbor would be
Yes.
10.2.
Okay. Remote AS.
100.
If it's ISP, it's 100.
100. Okay. Now let's go on ISP1. Here I'll say what router BGP say. 100. And the neighbor is what?
10.1.
Okay. Neighbor, it's 10.1. Remote AS will be remote AS
200.
100. Oh, 200.
Wait for a second. Or we need to check the neighborship. Neighborship is yeah, up. Let's configure let's make a neighborship in between ISP1 and R2. Sorry, ISP3 and R2. So let's go on ISP3. And then say first what router BGP say
100.
100. Neighbor is what?
Dot 40.2.
Remote AS
100. I mean 200.
Okay, and let's go on R2 now. On R2 we need to say what?
That'll be
200. Neighbor.
Wait, isn't it R2? Okay.
Remote AS
100.
100. Wait for a second for neighborship. Okay. Now I also create a neighborship in between ISP1 and ISP3 like this. Okay.
Okay.
Yes. So let's go on ISP1. Okay, on ISP1 we need to check. Sorry, on ISP1. Okay, on ISP1 we need to check we have any loopback or not. So no, we don't have any loopback. So we need to create a loopback first of all on ISP1. So loopback will be that is let's say the loopback IP will be 10.10.10.10 255 255 255 255. Correct. On ISP1 this is the loopback.
Okay.
On ISP3 as well we need to create a loopback. We need to check first of all we have any loopback or not. No, we don't have. So we need to create loopback 1 and the IP will be that is 30.30.30.30. Correct. On ISP1 we have 10.10.10.10.10 and on ISP3 we have 30.30.30. Correct.
Okay.
So ISP1
Okay.
is 10.10.10.10, the loopback, right?
Yes, the loopback. Correct.
And on ISP2 20.20.20.20.
No, ISP2 don't have any loopback right now. ISP3 having 30.30.30.
Okay.
Because now I'm creating a neighborship in between ISP1 and ISP3 IBGP loop IBGP neighborship IBGP indirect neighborship using loopback, right? So I'll say what router BGP say 100 and then say the neighbor is what?
30.30.30.30.
Remote AS will be what?
100.
And one more command we need to use what?
You need to
Right.
create
Give this
source of loopback
And then say router
interface.
BGP here as well 100 and then say neighbor remote AS 100 and we are using again same command what? Loopback 1. Correct.
Loopback 1. Yes.
Still the neighborship is down. Why?
You need to create an ISP3 also. Which is, oh, you created. So now you need to. Is the routing table available in each router? In each ISP?
Okay, I'll show you.
You're
Just to
missing
tell me, I'm not your
10.10.10.10.
trainer right now. Just to tell me what we need to do to up the neighborship.
You need to create an IGP protocol, EIGRP or OSPF.
Okay, so
Between
tell me how I can how I enable EIGRP on our on which router we need to enable that. Tell me the
in
command and all.
ISP1, ISP1, ISP2,
Okay.
and ISP3.
So what is the command?
The command is router IGP 10, let's say.
Okay. Then AS and then
I'm sorry, what?
The network, right?
Yeah, the network is
network.
10.10.10.10.
10.10.10.10.
10.10.10.10. Okay. And now
The net. You need to create also in ISP2 and ISP3.
okay.
Oh, you forgot to put the address.
What? Which one?
You forgot to put the mask here. Network 10.10.10 mask .255.255.255.
No need to configure the mask here.
Oh, okay, my bad.
Because this is the EIGRP, it uses wildcard bit and automatically it will be taking the
Oh,
mask.
okay.
Okay.
So
No
you
need
have to go to ISP2 and also create the same RG or
So tell me the command. Yeah, right now I'm on ISP2. The command is what? Router EIGRP 10 and then say what here?
2020.
Network 2020 here.
I think so, no? Or 10.10.10.10, sorry.
10 here or what?
Yeah, it's supposed to. Yeah, you need to add. Can you check what's available in the routing table first? So did you? There is no loopback created. So don't you create a loopback also?
Oh no, actually, what I can do here, I want like this ISP3 having a loopback 30.30.30.30. ISP1 is also having a loopback 10.10. I want to share this loopback here. I want to share this loopback here. Correct?
Yeah, he wants to do like an indirect neighborhood shift.
Okay, so then you have to add 10.10.10.10.
No. So if we need to enable a IGP protocol. So how to enable IGP? Actually, on ISP, you told me ISP1, we are saying only 10.10.10.10. So, you know, EIGRP is also making a neighborships. So we need to create a neighborship first of all. So here also we need to say 192.168.20.0. And on ISP2, we need to say router EIGRP 10. Router EIGRP 10. And then say network. Here we need to say network only the 20.0. Then automatically the neighborship is up. Wait. See, EIGRP neighborship is up.
Okay.
But this
right?
is
R1 having, see, ISP1 having this IP address. In ISP1 routing table, we have 10.10.10.10. Now this ISP1 will share this 10.10.10.10 to
the other one.
ISP2. See, ISP2 will receive 10.10.10. Now we need to create a neighborship in between R2 and R3. So we need to go on ISP2 and then say what? Router
EIGRP
10 network 30.0.
Exactly.
And on ISP3 as well, we need to say router EIGRP 10 30.0 as well.
Yeah, you need to add all the network. Basically, you need to add all the network.
And we need to, I want to share this as well. So I'll say 30.30.30.
Exactly. Okay, network. Exactly.
Now immediately the BGP neighborship is up. See?
Okay.
Because now if I'll show you on ISP1, do show IP route. So yes, it will be show me 30.30.30 route I can receive. And if I'll show on ISP3, do show IP route. So yes, I can receive 10.10.10.10. That's why immediately the neighborship is up. I'll show you do show IP BGP summary.
Okay, what's up?
So yes, ISP3 will show me what? I have two neighbor. Sorry, do show IP BGP summary. It will be show me I have two neighbor. 10, 10, 10, 10, 10. Who is 10, 10, 10, 10, 10? That is ISP1 and 40.2 as well. It means this R2.
Okay.
Because ISP3 having a neighborship with ISP1 and ISP3 is also having a neighborship with R2 router, correct?
Correct.
Okay, on ISP1 I also show you. Do show IP BGP summary. So here also it will be show me I have two neighbors, correct? Done. Any doubt till this point?
Okay. So far so good.
Now the concern is what? These are the two customer right now. This is the customer number 1 and this is the customer number 2. And right now customer number 1 is not able to communicate with customer number 2 and customer 2 is not able to communicate with customer number 1. Why? Okay, I'll show you. Let's go on R2 router. Like this is the customer number 2, right? And customer 2, what is the customer 1 IP address? Customer 1 IP address having a loopback that is 11111, right? And customer 2 is not able to communicate this 11111 right now. Why? Because that route is not available in the routing table. 1.1.1.1 route is not available in routing table, right? Exactly same. If I'll show you on ISP1, sorry, on
Hello.
Can you hear me? I can hear you, but I cannot hear the teacher.
Okay, no, I can hear you now.
Is he talking? Because I can't hear it.
I cannot hear it either.
Teacher, we can't hear you.
oh, I'm sorry. I'm muted.
Oh, you were muted. Okay.
Okay, what I told you here. Yeah. So what I told you, R1 router, R1 is not able to communicate to this 2.2.2.2.2, right? And R2 router is not able to communicate to this 1.1.1.1, right or wrong? Because R2 router is not receiving 1111 route in the routing table and R1 router is not receiving 222 route in the routing table. So what we need to do? Because R1 router right now don't share this route to ISP because I'm not using any network command. You know, I told you using the network command only that router will share this prefix, right?
Okay.
So let's go on R1 router and I want to share this prefix. So I'll say what router, BGP and then say what? 100.
100.
Sorry,
Network.
it's 200.
I'm sorry.
And then say network.
Network
1.1.1.1 and the mask will be what?
255, 255,
Correct.
255.
Now if I'll show the BGP table, do show IP BGP. So yes, I can receive the route in the BGP table. It means now this R1 router will share this route to the ISP1, right or wrong?
Correct.
Okay, now I'll show you on ISP1. I'll show you the command is what? Do show IP BGP and then say enter. So yes, it will be show me I can receive this 111 route with next hop IP, this one, correct?
Okay. Yeah.
Okay. Now on ISP3, if I'll show you on ISP3. So can you tell me ISP3 will receive this route or not do show IP BGP?
No.
Yes, I can receive this route, but this route is only on.
Valid, you need to be the best.
This route is not the best. So how now you know all the concept. Just to tell me what we need to do to make this path as the best. Tell me.
You can use static routing. You can use, I think, default route also, and also IBGP routing protocols.
Yeah, GRP.
Whichever you prefer to use.
Okay.
You need to add the EGRP.
Let's say what I'm saying. We don't have power to enable any IGP protocol.
Okay.
On the ISP.
So
we
yes,
don't have power to use any default route. We don't have a power to configure the static routing. Now.
If you can't use any IBGP protocol, the option
let's
would
say
be.
I don't. The concern is what? Here ISP says don't use any IGP protocol and I need static and default routing. So how I can Yes.
Do the whole, well, the mesh thing, full mesh? Or?
Full mesh. No, full mesh is not used to make a path any best. No, right now I want to make this path as a best.
Oh, yeah, right. To make the path best. Huh.
Check the previously, like yesterday I told you how many features we have.
Yes, we had several features, that's true. Hmm.
You both are the administrator right now in this ISP. Okay. In this ISP, we have 3 routers and you both are the administrator and you need to make this path as the best. Now you can do from your side. I'm not your trainer. I'm not any senior. You both are the senior network engineer. And now just to tell me how to make this path as a best.
But the thing is that we have no control on the ISP3, right? That's what you say.
And the concern is what? You don't have power to enable any IGP, default route, and static route.
On the ISP3, basically.
Yes.
So then how can you have to do an indirect connection? Indirect
No.
eBGP connection?
No, we don't do. The neighborship is perfect. No, you don't have power to change the neighborship here like that.
So you don't have the power to change the path.
But let me ask you a question. Basically, what we need to do now is connect the what is the one, the R1 with the R2, right? With the with the R2, these two at this moment.
Exactly.
That's what we have to do.
So that's what I said, use iBGP direct neighborship, but the problem is between R1 and R2.
No, you don't have power to change the neighborship as well. Right now, neighborship is in between R1, R3, so you don't have power to change that neighborship.
So basically, it's, I don't know, call the ISP and tell them to do it themselves?
No.
What I told you. See what I told
Okay, so
you
we are
right now.
Are we the ISP? Can we change anything?
You are the ISP, but you don't have power to change the neighborship, and you don't have power to configure any IGP protocol to make a path as the best, default route, and static route.
Well, we can manipulate the R1 and the R2, right?
No, if we are the ISP, but the problem is we don't have the power to do any of these. What's the option? How do we communicate R1 and R2 through our network?
Just to tell me, without changing, do these things without changing these things, can we make this path as the best? Yes, we can make this path as the best without changing those things. Yesterday I told you, but now I'm not telling you. You tell.
Yesterday you told us.
Don't worry, you can check your previous things. No problem. I'm waiting. No problem. You can. What you tell me if you will telling me show me the routing table or BGP table, so the table I'll show you if you want.
You can use a route map also. Can you use a route map?
We can just
yes, yeah, you can tell me, yeah.
Or
okay, next hop,
on the next hop itself.
Yes, these are the feature. Next hop self using the network command as well. We can do that.
Yeah, from what I have here, I have next hop self, network command, the static route, default route, and IGP.
Yes. So let's go on R1, sorry, ISP1, and just to use the next hop self command. Router BGP, say 100, and then say neighbor 30.30.30.30. Next hop self, because it's an edge device, right? And I told you the edge device, this command is working. Now just to do clear IPBGP star soft.
But wait. You say that we don't have control on the ISPs, right? ISP1, ISP2, ISP3.
Yeah.
Or yes.
No, we do. We are
Ah,
the
we do.
ISP, but he says that we cannot use.
No,
any
you are the
ISP.
ISP actually. You have power to do power, but you don't have power to do all the things. Like no need to. You don't have power to do the IGP configuration, static route configuration, default route configuration like that. So the option is what? The first option is what? You have power. You can configure the next hop self command as well. You can configure using the network command. You can also do this task. The third is what? Using the route map, you can also do this task. Okay. But the best option is what? Very easy. That is next hop self command. Now, if I'll show you on R3, sorry, ISP3, previously it will be show me the next hop pipe will be 10.1 with this. Now, if I'll show you, so it will be show me what 10, 10, 10, 10, 10. And this route is what?
The best. And valid.
Done.
So you need the next hop.
This route I also receive in the routing table. Done.
So that you added on the ISP1, right?
Yes.
What did you change on the ISP1 again?
The next hop self command.
Oh, the next hop self.
Just I'm using this command, this extra command.
Can you show me the command again?
Yeah, can you show us the
I'll
command?
show you just a minute. Yeah, I'm using this command. I can configure this command.
So wait, the neighbor 303030 next hop self. Okay.
Neighbor. Okay. But you can also we could use also the route map also, right?
Yes, we can also use route map.
Okay. What was the route map command again? Because I, for some reason, don't remember it.
Okay. Don't worry. I can explain you the route map command. Okay. Don't worry. Tomorrow, or if it is possible today. Today, first of all, I can explain you the filtering. How ACL, how to use a filtering like ACL, route map, distribute list, prefix list. Because when we are using a BGP attributes, so that those are very important. So first of all, we will discuss route map on these things. Don't worry. Okay. I told you. Okay.
Okay.
Yeah. So the first option is what? Next hop. Now, yes, this ISP3 will receive this route, correct?
Okay.
Done. Okay. Now let's check on R2 router. This R2 router. Do show IP BGP. I'm not receiving any route from the BGP in this router. Why?
So you need to do also the same configuration, the next hop self.
I don't know.
In this router?
Just to tell me, and you are the network administrator. These are the two, like you have these two customers, R1 and R2. And we can say both are the same, like both using a same AS. So it means we can say these are the branches, right? This is the branch number 1, and we can say this is the branch number 2. But what is the problem? Branch number 1 will share the route to branch number 2, but branch 2 is not able to receive the route. And just to tell me the reason, first of all, and how I can receive, tell me. Yeah.
Okay. Did
You
we configure
both are the
the
network
ISP
administrator here.
Are we receiving the route in ISP3? The network? Advertised by ISP1 and ISP.
I'll show you ISP3. It will receive a route or not. Do show IP BGP. See, ISP3 will receive the route 111.
Okay. And we already have established
route is not
BGP connection. Okay. Do we have established a BGP connection between? Yes, we are. ISP3 and R2. We have a BGP connection established. The only thing is,
yes, we have a BGP connection. Do show IPBG summary.
But not all the. Can you show us
Only
the
one.
IP route tables?
Yes, the IP routing table, yeah.
On
And
R2.
R2. Yes.
Yeah, on R2.
Okay, so we're missing.
11111.
Mm-hmm.
Yeah.
So we need
That is the
to.
problem.
Mm-hmm. You need to add it.
111 I'm not receiving on R2 in routing table as well. And if I'll show the BGP table, so in the BGP table as well, I'm not receiving.
So in this case, we can do like an indirect neighborhood shift, right? Between R1 and R2. Or not?
No.
If
Now,
he's
see,
receiving it,
ISP3 will receive.
Yeah, but he needs to share it to this one. So is ISP advertising also?
Yeah, is advertising network 111 or not? ISP3.
No, actually on ISP3, if this, you know what happening, I told you yesterday, whenever ISP3 will receive the route and this route is best and valid, then what happens? This router will install this route in the routing table. And yes, this route, it will be also show me the routing table. If it will be showing me the routing table, then 100% it will be share this route to our neighbor routers. 100%.
But why is it not sharing to this neighbor? Because it's already connected to the IBGP. It should be advertising.
Yeah, that is my question. Like why? Yes, this ISP3 will share this route to our neighbor 100%. But the problem is why this R2 is not able to receive that?
Can you show us the show IP BGP on the ISP3 again?
Okay. Do we show IP BGP?
No, but I mean the configuration.
The BGP configuration?
Yeah, sorry.
Wait, do show run 5-section router BGP.
Can you add what if you add the network here, the network command with the 111 here?
No. Actually, what happened? No need to use that command here, because what happening? Normally, what happen? If the route is available in the routing table, then 100% that router will share that route to the neighbor router.
It should.
And right now, yes, we have this route 111 route in the routing table. It means 100% this ISP3 will share this route to R2. But the question is why this R2 is not able to receive that route?
If we use the update source BGP command, no, right?
No, that command is used for the neighborship, and neighborship is up right now. You know, remember eBGP loop prevention mechanism?
Oh.
Can anyone explain to me eBGP loop prevention mechanism?
The eBGP loopback preventions. It was because what was it again? The difference between the IBGP and the eBGP is that if it sees the same ASN from the originating router, it will block it. So basically, to be able to receive it, to prevent this, you need to use allow as.
Correct. So right now, can you tell me, whenever this router will share this prefix to ISP1, so it will be sharing like this 1.1.1.1, and it will be putting the neighborship type is what? eBGP. So it will be putting the AS number, and the AS is what? That is 200, correct?
200. Since this is also AS 200.
ISP1 will share exactly same 200. ISP2 will share to ISP3 to 200. It means once this ISP3 will share to R2, so it will be sharing like this 1.1.1.1. It will be adding what? First of all, 200, and then it will be adding our AS as well, that is 100. Now, once this R2 router will receive this route, it will be checking, okay, the first AS is what? 200, and my AS is also 200. So what this R2 router will do, this R2 router will
it will block it.
Discard.
Ignore this route and discard this route, right?
So you need to use a neighbor allow as command, basically.
Yes, absolutely. So you need to remember, guys, these are the rules. You need to remember these rules, okay?
The thing is that there are so many rules now in like in one day is sometimes it's
Yes,
confusing.
that's why BGP is a very bigger protocol and very important. That's why.
It's too many rules at the same time in one day, We get
Yeah,
confused.
yeah. No problem. So just to say neighbor, neighbor is
Neighbor.
what? 40.1.
Allow us.
Say what?
Allow us
me.
in.
And just to use do clear IPBGP start soft. If I'll show you do show IPBGP. So yes, I can receive this route.
Okay.
Where did you configure that? In R2 or R1?
And R2.
On R2.
Can you show us the command again?
Yeah, sure.
Okay, neighbor. Okay. Neighbors. Okay, 40. Okay.
Done?
Yep.
Okay, perfect. So right now what's happening? R2 router receive the route 111 in the BGP table, right? In the routing table as well and in the BGP table as well. Correct? But if I'll show you on R1 router routing table do show IP route and do show IP BGP. So I'm not receiving 2.2.2.2 here, right? So what we need to do
the same thing.
if I want to
The same
receive
thing.
the 2.2.2, so
The same thing. Allow us neighbor. I mean neighbor network neighbor. Dot
okay, so
two
tell
dot
me
two
one
dot,
by
I
one,
mean,
one by one. Where we need to do, we need to configure where? On
in
R2,
R1.
R1 where?
In R1, you need to configure.
On R1? What command
Yes.
we need to use on R1?
You need to use the allow us command there.
No, but when
Oh,
we
you
are
need.
using that allow AS command, when the ISP1 will receive the route.
Oh yeah, but right now it's not receiving it because you need to redo what we did from R1 to R2. We also need to redo it from R2 to R1.
Yes. So what I can do, tell me.
So basically what we did first, we need to see if the route is best. We did it with next hop self we need to start from ISP3. See, we receive the 2.2.2.2 and see if from ISP3 receives it to ISP1.
Okay. So we need to check on ISP3, right? First.
Yes.
Right now I'm not receiving 2.2.2 route.
Oh, you're not receiving. So we need to redo in AS in router 2. You need to announce IP saying network 2.2.2.2 mask 255
yes.
to.
Great. Superb. So here we need to say 2.2.2.2 and then say what? Mask
255, 255, 255, 255.
Now, yes.
Okay, perfect.
It will share this
so
route.
now you have to, yes.
Now
Now
we need to check
ISP3
where?
if it's receiving it.
Right. Okay. Superb.
Okay, perfect. It's receiving it. It's fast. Now we need to check in ISP1 if it's receiving it.
Superb.
So it's not best. So to create it best, we need to do the next hop self from ISP3. We need to configure that in ISP3, was it? I think so, yeah.
What is the command?
Next hop, wait a second, what was the command again?
Are you sure we need to configure on ISP3?
No, in ISP2, sorry.
ISP2?
Can you check in if we're receiving the router in ISP2?
Okay, this is the route. Like right now, ISP1 will receive 2.2.2 and this route is not best. So where we are using a next hop self command?
It has to be on ISP3 then.
ISP3? Yes.
Yes.
What is the command router BGP say? 100.
The command for next hop self is neighbor, wait a second, the network next dash off dash self.
Do clear
Right.
IP BGP.
Let's check
Soft.
on RESP1 again. Done.
Okay, perfect.
This route is best and valid, right?
Yes.
Now let's check on R1, I think, right? R1 is not receiving.
No, we need to check if we're receiving in ISP1.
Okay. Yes, ISP1 will receive it.
He will receive it. Okay, then so then we'll do the allow us in R1.
200.
Neighbor to the
10, 10, yeah, 2.
192.10.2.
Allow us in.
Allow us in.
That's it. Now check again.
You need to do the clean IPBGP soft. Boom.
Correct.
We got it.
Super.
Gotta
So it
remind
means
rules.
yes, these routers will receive the route. Correct.
Mm-hmm.
But the problem is what? Again, I want to do a ping. Still, I'm not able to communicate.
Really?
Why?
If it's receiving the route and everything, why is it not? What is the routing table? Do you have available in the routing table in R1? Yeah, it's supposed to be there.
So how to troubleshoot it? Like, tell me what I can check.
Check the IP route, the IP route, the table.
It's there.
Do we have to do like a static IP, a static route or not in this case?
No, when the route is available, so why? That route is available. Okay. Now I'm telling you, don't worry. Do ping. I'll do a ping. Do ping. 2.2.2.2 with source IP what 1.1.1.1. Correct.
Okay. Mm-hmm.
If I'm entering this command, so what happening?
Because
The
it's not a
device
physical
will
interface.
send the source IP 1.1.1.1, and the device will send the destination IP is what? 2.2.2.2. Correct. But still, I'm not able to communicate.
Oh, really?
Why? Yeah. What is the problem? Don't worry, I can explain you. So the source IP will be what? 1.1.1.1. Destination IP is what? 2.2.2.2. Right?
Oh,
now,
I know.
Router,
is it because
R1
you have to do?
Router will check what? Now R1 router will check the destination IP is what? 2.2.2.2. Now look up the routing table. In the routing table, we have 2.2.2.2. Yes, we have.
But be at .1.
And if I want to communicate to this 2.2.2.2, then we need to forward the packet where?
10.2. Yes.
10.2. So actually, this R2 router will share this packet to 10.2. Now, ISP router will receive the same packet. ISP router will receive a packet with the source IP what?
10.2.
No,
destination IP is what?
2.2.2.
Okay, now when this ISP1 will receive the packet, so they will check a destination IP that is 2.2.2. Now it will check the routing table. We have any 2.2.2 route in the routing table? Yes, we have.
No.
And if I want to communicate to this 2.2.2.2, then we need to send the packet where?
To 30.30.30.30.
It means R3. But it will be show me if you want to forward the packet 2.2.2.2, then we need to need to go where?
30.30.30.30.
And it will be show me if you want to communicate to this 30.30.30, then we need to go where?
20.1. I mean 20.2.
And if you want to communicate 20.0 network, then we need to exit the packet from which interface?
0/0.
It means this is like this, that router will look up the routing table actually. Okay. ISP1, actually what happening, once this ISP1 will receive this packet with source IP 11111, destination IP 2.2.2.2. So that router will always check the destination IP. The destination IP is what? 2.2.2.2. Now router will look up the routing table. We have any 2.2.2 route? Yes, we have. And if I want to communicate to this 2.2.2.2, then we need to send the packet where? 30.30.30.30. And it will be show me if you want to send a packet to 30.30.30, then we need to send the packet first of all on 20.2. It means we need to exit the packet on which interface?
20.
Okay.
F0 by 0. So actually this ISP1 will send this packet here, correct? Now ISP2 will receive the packet again. The source IP is what? Destination IP is what? Right. Now ISP router is also look up our routing table. When this ISP2 will receive the route, with source IP 111, destination IP 2.2.2.2. So this ISP2 will check the destination IP. The destination IP is what?
2.2.2.2.
Now this ISP2 will look up the routing table. In the routing table, we have any 2.2.2.2 route?
We don't.
No. What this ISP2 will do?
It will drop
the packet.
Because it was,
so this is what? Problem.
Okay. So you need
and
to
why
what?
this
You need to
ISP
change.
don't receive the route 2.2.2.2? Because I'm not enable the BGP on ISP2.
So you need to.
And I don't want to enable the BGP on ISP2. So the problem is what? The packet is dropping on R2 router, right? And this is called what? This is the problem actually. See, the routes are shared to end. Are you getting a point? The routes are shared to end, but still I'm not able to communicate. And router will, this on ISP2, that router will drop the packet. Are you getting my point? The problem is what? End to end, the route is shared. The route will show me in the routing table, but still I'm not able to communicate. Right? Because the packet is drop on ISP2.
Yep.
Now the solution is what?
The solution would be to, I don't know what to say. I mean, configure the ISP2 as a RR.
But when I configure this ISP2 as a RR, no, RR is not a no. Because I don't want to see. Actually, I'm enable the BGP on ISP1 and on ISP3. I don't want to enable the BGP on ISP2. Because you know the BGP routers will receive lakhs of routes. And this is not a high configuration router, let's suppose. And this router is also receiving 1 lakh routes. This router is also receiving 1 lakh route. But I don't want to receive those 1 lakh route on ISP2 because this is a lower series router.
Yeah, so we cannot use IBGP, you tell us, right? We cannot use static route, you cannot use IGP, we cannot use was a default route. So right now we're doing the next hop self. So the other option to be able to communicate, let me think.
Actually, the problem is what? The neighborship is up. A route is also exchanged to each other end to end. R1 router will share our route to R2. R2 router will receive 1.1.1.1 route. R2 router is also share our route to R1. R1 router is also receiving 2.2.2 route, but not able to communicate. Because on R2 the packet is drop. So this is called what?
Because it's not in the routing table. So, but we cannot add it
We can
in
say
the routing
backwards.
table unless.
So the solution is what? Right now on ISP3 will receive what? ISP3 and ISP1 will receive 2.2.2.2 route in the routing table, but ISP2 don't have 2.2.2.2 route in the routing table. So the solution is what? The solution is on ISP I also enable the EIGRP, right? On ISP2.
Well, wait a minute. You said that we can use IGP protocol routing.
Exactly.
You said we couldn't use it.
Wait. On ISP3, I'm using EIGRP. On ISP2 as well, I'm using what? EIGRP. On ISP1 as well, I'm using what? EIGRP, let's say. So the solution is what? We can redistribute the route from BGP to EIGRP. Then this ISP2 will receive the route, right? Because on actually what happened?
That you didn't allow us to use ISP.
On
EIGRP1,
I'm using EIGRP. Here also I'm using what? EIGRP. Here also I'm using what? EIGRP. Here I'm also using BGP. Here I'm not using BGP. Here I'm using what? BGP. So what we need to do? We can redistribute the route from BGP to EIGRP. Then yes, this EIGRP will share that route to EIGRP. It means yes, this EIGRP will receive 2.2.2.2 route. But right now, I'm not using any IGP protocol here, correct?
Correct.
If I'm using a EIGRP, then yes, we have power to redistribute the route. Okay. So we need to use the IGP protocol here actually.
But I thought we couldn't use it. That's where we were stuck. Like, okay, can't use it. How can you do it?
See, there are many things here actually. Actually, the concern is what? The packet is drop here. On ISP2. So let's say I'm using IGP protocol. ISP1. So it means what? ISP, I'll show you ISP to do show IP. I'm enable the EIGRP on R1, on R2, and on R3, right? So here also I'm enable the EIGRP. Here also I'm enable the EIGRP. Here also I'm enable the EIGRP and BGP, BGP. So still, if I'm doing a ping from R1 to this 2.2.2.2, still it is not communicating because the packet is dropped again on ISP2 router. Here the packet is dropped because in ISP2, because in ISP2 routing table, the 2.2.2 route is not available here.
But why isn't it supposed to be receiving it with the IGRP, no?
Actually, why it is not receiving? Because we need to do a redistribution here. Because BGP will receive 2.2.2.2 route. BGP will receive EIGRP is not receiving. So what we need to do? We need to perform a redistribution here. Then it will be receiving. Okay, I'll show you. I can do that.
Okay, I gotta write that down.
Let's go on ISP3. Performing a redistribution from BGP to EIGRP, because can you see here? Right now it will be show me I can receive this 2.2.2 route from BGP, right? So we need to redistribute the route. I'll say router from BGP to EIGRP. We are doing a redistribution. So I'll say what? Router EIGRP 10, and then say redistribute BGP. I want to redistribute 100 AS, and then say metric bandwidth will be 100, 100, 255, 255, 1500. Done. Redistribution is done.
Wait a minute. What was all that?
ISP2.
Don't tell me that now works.
Do show IP route. Yes, I can receive 2.2.2 route now.
What is the XEX on the left side?
DEX. This is what redistributed route actually. Redistributed route. External route. Okay. Now ISP2 will receive the route. But the problem is what now? Again, we have a problem. What problem? On ISP1, we have 10,000 routes. Let's say not 10,000. We have 10 lakhs route. On ISP1 and exactly same on ISP3. Okay. And when we are performing a redistribution on ISP3 from BGP to EIGRP redistribution. So what happening? This ISP2 is also receiving these 10 lakh route, correct? And I don't want to receive those 10 lakhs routes. So it means redistribution is not a best option. If I'm doing a redistribution, then this router is also receiving those 10 lakhs route. Correct? Yes or no?
Yep.
Yes.
And I don't want to receive those 10 lakhs routes because this is the lower series router. So redistribution is not a good option. When I'm enable the redistribution, then yes, the communication is done. See, I'll show you. Communication is not happen. Why? Okay, we need to do a redistribution on ISP1 as well. Both sides we need to do a redistribution. Router EIGRP10 redistribute BGP. Say 100, 100, 100, 255, 255, 1500. Now yes, I'm able to communicate. See.
So what is the one you add now? The last command?
Actually, see, what happened? Why previously not able to communicate? Here we are enable the EIGRP as well and BGP as well. Here also I'm enable what EIGRP as well, and then what BGP as well. And here I'm enable what EIGRP. So right now this RISP2 don't receive the 10 lakh routes because I'm not performing any redistribution. Let's say I'm performing a redistribution from BGP to EIGRP here as well, and from BGP to EIGRP here as well, right? So from ISP3 it will be receiving 10 lakhs route. From here it will be receiving, and from here as well it will be receiving 10 lakhs route. It means 20 lakh routes this ISP2 will receive, and this is not a good thing. Why? Because this is the lower series router and I don't want to receive those routes. So it means both the side, if I am performing a redistribution, so the communication is done, but this router will receive 20 lakh route. So this is not a good thing. It means this is not a best option. The redistribution is not a best option.
It's just like an emergency use, just in case. But what was the command again?
Yes.
So I can write it down because I didn't remember the command. Oh, to redistribute the. So the command is redistribute. Okay, redistribute.
The command is router EIGRP 10, distribute BGP 100 metric.
So you put you put BGP ASN, right, number, then metric.
Yes.
You just repeat
Yes, this is
ASN
AS
and
number.
ASN.
So by doing
Okay.
this command, redistribute BGP metric 100, 100. So what does this command do?
This is actually the metric. You know, EIGRP uses metric, bandwidth, delay, MT reliability. 5 things EIGRP uses. So these are those 5 things.
So okay, wait. You are configured this on ISP1. So redistribute BGP 100. Okay. And the metric. What the metric means? You put
exactly.
Metric. It means, you know, when you are right now, I'm redistribute the route. Like I'm redistributing BGP route into the EIGRP. So we need to define the metric, like what metric I'm setting. So I'm setting here this metric because EIGRP uses what? Bandwidth, load, delay, reliability, MTU. So this is what MTU 1500. This is what reliability 255 is a more reliable. This is what load 255, and this 100 is what bandwidth, and this 100 is what delay.
Wait a second. Let me wait. Don't. So you have to put the bandwidth, the load.
Oh, but this is something new, right? Oh my god.
Yeah, that's
No, it is not new. When you do always we need to define it. Once you redistribute any protocol in the EIGRP, then always you need to define the metric 100%.
What is the third one? The third one is what up?
First is what bandwidth, second is what delay, third is what reliability, fourth is what load, fifth is what MTU.
Reliability.
Yes, because EIGRP uses these 5 K values to find the best path. So whenever any protocol will redistribute in EIGRP, so we need to define what metric that you want to use manually.
Okay, but for example, the first 100 that says bandwidth, right? What does it actually mean? 100 bandwidth, what is that?
100 megabytes?
Actually, what happened? It will calculate the metric. It will okay, I'll show you. Wait, give me a second. I'll show you on ISP. Can you see here this metric? Okay, wait. Give me a second. 2.2.2.2 I can receive from 30.2. Okay. Right now the metric is this one, correct? Now let's go on ISP3 now. And I'm doing some changes here. Previously I'm using this command. I'll say no this command. Again I'm say redistribute BGP 100 and then say metric I'm saying 1000 delay. 255 is reliable and this is also load is very reliable, this 255, and I'll say enter. Previously it will be show me this metric, right? Now again if I'll show you here, so
It's the same, right?
previously it will be show me this metric here. Now if I'll show you, so it will be now the metric will be changed.
No, but it's the same in this case.
We need to check for 22222. See.
Oh, so let me see the other one, the one before.
I think both are same.
Yeah. Do you have to clear maybe the BGP connection?
Wait. 281. See, previously it will be show me this one.
8160, and now
for 22222 it will be show me 126, and here for 2222 now it will be show me what 1281.
Okay.
It means
Okay, I'm lost.
when I'm changing here, so it will change the metric here. So you can put anything else here. Okay, right now we are not making any path as the best because metric basically we are using to make as a path best. So right now I'm taking any value here, but when you are doing in real network this redistribution and we need to define the matrix, so we need to check all the things, then we need to define the metric.
Are we going to see
because
this command more
metric, the path is big best. What
are we going to see this command more in depth? Because it seems like it has a lot of different functions or something. Like for example, these attributes. I think they're more valuable. I don't know if you're going to see this command in the future during the course.
actually this is the part of the EIGRP, no problem. Guys, we will discuss these things once we start the redistribution BGP. Don't worry, okay?
Okay.
Yeah, we will discuss this. Don't worry, okay? We will discuss in part of redistribution. Okay, we will also do a BGP redistribution separately. BGP redistribution. So I'll show you how to redistribute. How to redistribute OSPF to BGP, EIGRP to BGP, RIP to BGP, static to BGP, and BGP to EIGRP, BGP to OSPF, BGP to RIP, BGP to static. Okay. Yes.
Okay, those.
Okay. So I hope this thing is clear to you, right? Right now, once we are performing a redistribution, again we have a problem. Once we are performing a redistribution, the communication will happen. No, that is fine. But the problem is what? This router will receive all 10,000 routes, and that is I don't want. This router, this ISP is also receiving 10 lakhs route. This ISP is also receiving 10 lakhs route, but this ISP2 is not receiving the 10 lakhs route. Once I'm performing a redistribution on ISP3 and ISP1, then this ISP2 is also receiving 10 lakhs route, and that I don't want. So the second option is what? Redistribution is not a good option. Now the second option is what? That is synchronization. In the synchronization also we need to do a redistribution. The second option is what? That is synchronization. But nowadays in a real network, we are not configuring a synchronization. We are configuring a MPLS. So the best option is that is MPLS actually.
Okay.
This thing we will discuss after the lunch. Okay. So after the lunch, what I can explain you, I can explain you first of all the synchronization. What is synchronization? Okay. Actually, the problem is what? The packet is drop here. And this is called what? This is called BGP. loopholes. This is what BGP loopholes. Actually, I'm not configure the BGP here. I configure the BGP here and here, and the packet is dropped on ISP2. So this is what loopholes. So to reduce these loopholes, we have a two feature. The first is what? Synchronization. The second option is what? MPLS. Right? So after the lunch, we will discuss here what? Synchronization. Then I told you what is the problem in the synchronization. Then we will discuss MPLS as well.
Okay.
Not depth. We will something like MPLS. Okay, the MPLS command only.
Awesome.
Yeah. So let's have a lunch.